Welcome to Mindset 100% Lessons. In this lesson, I'll be focusing on a math topic, which is trigonometry for grade 11 and grade 12. So I'll explain the aim of this topic, what we are actually aiming to achieve in this whole topic, right? So for grade 11 and 12, we are basically trying to achieve, or we are basically trying to find out what are the ratios of different trigonometric functions, right? For example, if I have maybe a trigonometric function of sine, so I want to know what is the ratio or what is the value of sine theta, right? Maybe, for example, I want to know what is the value of sine 45, right? So this is the main aim. What is sine 45? Or alternatively, another example that I can give is I want to know the value of cos theta, or maybe I want to know the value of tan theta, right? So if I can give another example, maybe let's say sine 60, right? So it means that the theta is 60. Sine 60, I want to know what is sine 60, I want to know what is cos 60, and I want to know what is tan 60, right? So that is the whole aim of this exercise, or the whole aim of this lesson. But now what you have to note is that for these trigonometric functions, your angle, which is angle theta, should be less than 90 degrees. Then it means theta is an acute angle. So it means theta is actually less than 90, right? So every time we try to find the trigonometric ratios of the different trigonometric functions, we have to make sure that theta is less than 90, right? So to simplify this, I will use different regions. So region number 1, we have angles which range from 0 degrees up until 90 degrees, right? And all these angles that are ranging from 0 degrees to 90 or to less than 90, all these angles are acute angles, okay? So this is where we want our theta to be, which is less than 90, okay? So the second region is from 90 to 360, which is a full revolution of a circle, okay? And then the last region is actually greater than 90. So we have 3 regions here, okay? So I have region number 1, whereby I have an acute angle, and this is where I want my theta to be. And I have region number 2, which is from 90 to 360, and then I have region number 3, which is 360 degrees and above, okay? So now, as I said, we want to operate within this region, which is region number 1, okay? So we want all our angles to be in this region in order for us to evaluate the ratios of the trigonometric functions, which is sine theta, cos theta, and tan theta, right? But then now, what happens if you have an angle which is greater than 90, or maybe you have an angle which is greater than 360, right? So what we have to do is, let's say for example you have an angle in this region, which is region number 2, right? What you have to do is to make sure that you are able to reduce this angle in order to take it to the first region, which is from 0 to 90 degrees, right? And also the same applies if maybe you are in this region, which is 360 degrees and above. For you to evaluate, or for you to get the ratios of the different trigonometric functions, you have to reduce this angle and be able to take it to the first region, which is from 0 to 90, because we said that your theta should be less than 90, right? It should be an acute angle. So if maybe, for example, you want to evaluate sine 160, okay, 160 degrees. So 160 degrees is above 90, so it's not in the first region, right? And 160 is actually in the second region. So you have to find a way in which you can reduce this angle and then you take it to the first quadrant, right? And then another example, maybe let's say you have sine 720, for example. So now you can see that 720 is not in the first region, which is 0 to 90, right? But 720 is in region number 3, which is 360 and above, because 720 is above 360 degrees. So you have to find a way of taking that 720 degrees to the first region, which is from 0 to 90 degrees, right? So in this lesson, we'll be learning on how can we actually reduce angles which are in the second region to the first region, or maybe to reduce angles which are in the third region to the first region, because this is where we want our theta to be. So let's start with angles which are in region number 3, right, which is the purple region, which is angles which are greater than 360 degrees. All right, so let's say you have an angle of, for example, 600. Okay, you can see that before you evaluate the value of sine 600, or the value of cos 600, or maybe the value of tan 600, right, you have to reduce this angle such that you get a reference angle or an equivalent angle which is in the first region, which is between 0 and 90, right? So you have to reduce this angle into this region. So how do you actually do this? So now, if you have an angle which is greater than 360, okay, for you to reduce this angle, it's possible that you can reduce this angle into the second region, right? Mind you, 600 is in the third region. You can reduce this angle and then you find that it falls under the second region, right? Or you can reduce this angle and then you find that it falls in the first region, which is where we want our angles to be, right? So now, the general rule is that if an angle is greater than 360, for you to reduce that angle, you just have to subtract 360, okay? So for us to reduce this 600 degrees, what we have to do is to say our new theta now is 600 degrees minus 360, okay? So it means our theta is equals to 240 degrees, right? So we took this angle from the third region, which is a region which is greater than 360, right? And then the general rule is that you just have to subtract 360 from that angle in order for you to reduce that angle into the second quadrant, or the second region or the first region, right? So we see that we had 600, so it means sine 600, this is equivalent to sine 240, right? The same applies to cos 600. This is the same as cos 240, right? And then it means tan 600 is the same as tan 240. But now we have reduced this angle from the third region into the second region, because 240 degrees is in the second region, which is greater than 90 and less than 260, right? So it means we have to furthermore reduce this angle, which is 240, into the first region, which is from 0 to 90. So now for the second region, which is the blue region, for you to reduce angles in this region and take them to the first region, which is where we want our theta to be, it's not a general rule whereby you say you just subtract 360 as in the third region, right? So remember, if an angle is greater than 360, you just have to subtract 360 and then you get that reduced angle, right? But then in this case, what we got, we reduced 600 degrees. So you first have to identify where is your angle, right? 600 is in the third region. So what do we do in the third region? You just have to subtract 360. And then now after subtracting 360, right, you evaluate your angle, you check your angle. Your angle is now 240. Where does your angle fall? Does it fall in the first region or the second region? And then we can see that 240, it falls in the second region. But then now, how do you actually take angles in the second region into the first region, which is where we want it to be, right? So in this case, you'd have to use what we call reduction formulas. So any angle which is in the second region, you have to reduce it using what we call a reduction formula, right? Okay, so we have three formulas that we use to reduce our angles, which are in the second region to the first region, right? So we have three formulas to reduce angles which are in this region into the first region, okay? So what do we use actually? We use what we call a cast diagram, okay? So what is a cast diagram? It is a diagram showing the sign of each trigonometric ratio in each quadrant, right? And the cast diagram is labeled as follows. So in the first quadrant, we have that A, which means all trigonometric ratios are positive. It means sine is positive here, cos is positive here, and tan is also positive here, right? But then in the second quadrant, we have sine only, which is positive. Then it means cos is negative here, right? And also tan is negative here. And then we have tan here, which is positive. It means sine here should be negative, right? And also cos should be negative. And in the fourth quadrant, we have cos, which is positive, and the others should be negative, right? So that is the cast diagram. C on the fourth quadrant, A on the first quadrant, sine on the second quadrant, and on the third quadrant you have your tan. So that is your cast diagram. So now, what are the formulas that we use? I said we have three formulas, right? So remember, this is a Cartesian plane, and if I had to label the degrees, that would be 0 degrees, and then from the x-axis to the y-axis, that is 90 degrees, and then here it's 180 degrees, 270 degrees, and 360 degrees, right? And if you go for a second rotation, then it means your angle is greater than 360. But how do we actually solve for angles that are greater than 360? We just subtract 300, right? I mean 360. And then it's either you reduce that angle into the second region or into the first region. So now let's say we have an angle which is in the second region. How do we actually reduce it? I said we use a cast diagram, right? So in the cast diagram, we have three formulas that we use to reduce angles into the first region. So now if you look at your cast diagram, this is your cast diagram, and in your cast diagram, it shows you different regions, right? If you can check this region ranges from 0 until 90, right? So this is the first region. If we can compare it with the first diagram that I drew, that is the first region here, from 0 to 90 in that Cartesian plane, right? So we basically want all our angles to be in the first quadrant. So theta should be in this quadrant, right? But now, what are the three formulas that we use to reduce angles which are between 90 and 360 into the first region or into the first quadrant? So now in the second quadrant, the formula that we use is 180 minus theta. So it's 180 degrees minus theta, right? And then the third quadrant is 180 plus theta. This is the formula that we use to reduce angles to the first quadrant in the third quadrant. And then in the fourth quadrant, we use 360 degrees minus theta, right? And in the first quadrant, it's just theta, and that is what we want. So now you have to identify your angle first, okay? After identifying your angle, if your angle is greater than 360, what we concluded is that you just subtract 360 in order to reduce that angle. But then what if your angle is between 90 and 360? For example, the example that we're doing now, we said we are reducing this angle, which is 600, right? And then we can see that 600 is greater than 360. So it's in this region, which is the third region. So how do you actually reduce angles which are greater than 360? You just subtract 360. And then we said 600 minus 360, and then we got 240, right? So now we still have a problem with this 240. It is not in the first quadrant, or it is not in the first region, whereby we say we want an acute angle, right? So an acute angle should be less than 90, and this is 240. Therefore, we can conclude that 240 is in this region, okay? And in this region, we use reduction formulas, right? So if we use reduction formulas, we use it hand in hand with our cast diagram. So let us locate 240. Where is 240 in this Cartesian plane? So now you can see that you have 0, 90, 180, and then 270, right? So it means 240 is less than 270, but it is greater than 180. So 240 is in this quadrant, right? So how do we actually reduce these 240 degrees using this reduction formula, which is 180 plus theta, right? So in order for you to reduce that 240, you'd have to say 180 plus which angle actually, because this is the reduction formula that we're using, right? So now we'd say 180 plus which angle here that would add, and then it will give us 240, and that angle is 60 degrees, right? So 180 plus 60 degrees is 240. So now we have reduced that angle in order for us to get that reference, which is 60 degrees. Therefore, our theta is 60 degrees. Okay, so now we can conclude that maybe tan 240, okay, or sine 240, and also cos 240. This is equivalent to tan, as we said that that is in the third quadrant, right? And the reduction formula in the third quadrant is 180 plus 60, okay? And this is also the same as sine 180 plus 60, because the reduction formula says 180 plus theta in the third quadrant. So that would be cos 180 plus 60, okay? So that is how we reduce our angles. And now if we want to further simplify these trigonometric ratios, you'd have to check the sign of that trigonometric ratio in the quadrant. So for example, 180 plus 60, which is tan 240, right? That is in the third quadrant. And tan, we concluded that tan is positive in the third quadrant. So that would be the same as tan 180 plus 60. This would be positive tan 60, because that is our theta, right? And now if we say sine 180 plus 60, since we are reducing that angle to 60, and we concluded that sine is negative in the third quadrant, right? So that would be negative sine 60. And then cos 180 plus 60, we also concluded that cos is negative in that quadrant, so that would be cos 60, right? So that is how you reduce angles which are between 90 and 360. But then for angles that are greater than 360, you just subtract 360 and then you see where it lands, right? So now let us check that tan 60 that we got. Is 60 degrees an acute angle? The answer is yes. 60 degrees is less than 90. So 60 is an acute angle. All right, so let us do another example. Let's say 120 degrees, right? We want to evaluate sine 120 degrees or cos 120 degrees, maybe, and tan 120 degrees, okay? So now let us identify this angle. Is this angle an acute angle? The answer is no, this is not an acute angle, right? But then now, where does 120 degrees fall in this region? 120 is actually greater than 90, right? Therefore, it falls in the second region because it is also less than 360. So 120 degrees falls in this region. And in this region, I said we use reduction formulas, right? And now let's see, where does 120 fall? 120 degrees is less than 180 but greater than 90, so it falls in the second quadrant, right? So in the second quadrant, which reduction formula do we have to use? We use 180 minus that theta, okay? So now I would say this is equivalent to 180 minus a specific angle, right? Because this is what the reduction formula is telling me. Minus a specific angle for me to get that 120. Then I'll have to minus 60, right? And same thing applies to this one. That would be cos 180 minus 60, because I'm using reduction formulas. Why am I using reduction formulas? Because this angle is not an acute angle. And then now tan 180 minus 60, right? I've applied the reduction formulas. But now let us simplify it considering the cast diagram, right? So where is this angle actually? What is 180 minus theta? It's in the second quadrant, and only sine is positive in the second quadrant, right? So therefore this would be positive sine 60, right? But then if you want to evaluate cos 180 minus theta, it is still the second quadrant, right? But in the second quadrant, cos should be negative because we indicated that cos is negative and also tan is negative. Only sine is positive. So that would be negative cos 60, right? And that would be negative tan 60 because tan is also negative in the second quadrant. So that's all for this lesson. What we can recap is that we learned that we want to reduce angles, right? We want to reduce angles into an acute angle. So what is an acute angle? Is an angle that is less than 90 degrees, okay? So what do we do if angles are greater than maybe 360? If an angle is greater than 360, you subtract 360 degrees, right? But then if the angle is between 0 and 360, you'd have to apply the correct reduction formulas.